What's going on, you guys? Mr. Allen here with some piecewise functions, and I got some questions regarding this piecewise function that has been graphed. If you don't know how to graph these, I did make a video on exactly this problem right here and showed you guys how to graph it, so check that one out. I'll link it in here right now. So if you're like, wait, how do we even graph this? Go back to that video first, then come to this one. So here, I want f of 2 equals what? F of negative 3 equals what? Then we got like the reverse going on here, and then intervals of increasing and decreasing. So 6 dope questions. Let's get after it. F of 2. So if we look at our graph, when x equals 2, I'm looking right here. Well, which one do I pick, right? Well, it's open here, it's closed here. So the closed one is the answer. And sometimes we give you this question without the graph already here. So here's how you'd identify it in the piecewise function itself. So here it says x is greater than or equal to 2. So x equals 2 with this function here, this is the one you got to use, okay? Had the equal sign been over here with this inequality and not with this one, then I'd be using this function. My answer would have been 4, okay? Just got to look at which one is it equal to at that time. And oftentimes we do, as math teachers, pick the ones that are our domain restrictions, those critical points there, where you'd have to know which function am I using, okay? So let's see what happens here, f of negative 3. So if I look at just this function here, which one am I going to be working with? Well, here is equal to negative 3, so it's this function that I'm working with. Not the first one here because it's not equal to negative 3. So we could just plug it in here. Negative 3 gets plugged in. That's negative 2 squared is 4, minus 5 is negative 1. And let's see if it checks out on the graph as well, because we could ask these questions just given a graph. You have to read that as well. Well, over here, if I look at f of negative 3, I'm looking at this green guy right here, not the open pink circle, so I would be picking negative 1. So either way, it checks out, whether you look at the function or you look at the graph. We could give you either one. We could give you both. It just kind of depends on the scenario. You need to be fluent in reading graphs, functions, and even tables, okay? So over here now, the reverse. F of x equals 0, what does x equal? Well, when does f of x equal 0? What is my... So next one here, we got f of x equals 0. What does x equal? Well, let's see here. F of x equals 0 along the x-axis. That's when my y values are 0. And it looks like it's this point right here, which is between 1 and 2. I'm not exactly sure where. So let's go back to our functions, right? This is the quadratic function, x plus 1 squared minus 5. Perhaps there's a way to solve this. I'm going to do it right over here. So if I took x plus 1... squared minus 5, and I set that equal to 0, I could solve this, right? I could solve this guy here. So I'm going to add 5 first. I got x plus 1 squared equals 5. Square root both sides. X plus 1 equals plus or minus the square root of 5. I don't know why I kept the parentheses there. You don't need them anymore. But here's the thing. Am I going to want the positive root 5 or the negative root 5? Well, since we're over here, I'm going to be using the positive root 5. Had it crossed over here, I'd be using the negative root 5. Or if it actually happened on both, I'd give the two answers. So we'll only be working with the positive root 5. So here I'm going to subtract 1 on both sides, and I'll get x equals positive root 5 minus 1. And that would be my positive root 5 minus 1. That'd be my final answer there. Or negative 1 plus root 5 would also suffice. So if you'd rather, you would have... negative 1 plus root 5. Some might prefer that. I think I actually kind of prefer that. But I wrote that one down first. So whatevs. Alrighty, so there we go. So we got our solution there, our x value that would give us 0 for our output, right? Now let's see if f of x equals negative 5 is maybe hopefully a little bit easier. Let's see. Well, when does f of x equal negative 5? So that'd be down here. Ooh, I've got actually two values. At it looks like at negative 1 and If we come over here, it looks like 1, 2, 3, 4, -4. There we go. So at -1 and at -4, my outputs would be 0. You can even test that. If I plugged -1 in here, I'd get 0 squared is 0 minus 5 is -5. And if I looked at the pink one here, which is the top function, if I plugged in -4, I'd get -8 plus 3 is -5. So it checks out whether it's here or here, okay? We probably wouldn't ask this question given just the functions. That'd be a little tricky. Usually this question is asked given a graph of a function or a piecewise function or something like that, okay? So not usually something we do with just the equation. Now let's take a look over at the intervals of increasing and decreasing. When are these graphs increasing? Well, it looks like this pink one here, although the arrow's pointing down, remember you think of increasing and decreasing from left to right. So I am going up as I go to the right. So I am increasing from -infinity to, it looks like, -3, not including the value. And whenever I'm talking about intervals of increasing and decreasing, I never actually include any of the values because it's talking over like a span of points, a range of points there. So you can never really say it's increasing at one given point. So technically, even if this is a closed dot, I would still use a parenthesis. They're not too nitpicky on that, I believe. When you get to like AP calculus, they're more so just concerned with the values. But I believe that's the technical way of doing it. All right, are there any other intervals here? Looks like at -1 on up to +2. This whole stretch is also increasing. So we do a union, and we would say -1 to +2. And notice, again, I only did parentheses there, even though this point is on there. It's actually a point at that vertex there. It's neither increasing or decreasing. It's horizontal at that instant, if you will. The tangent line would be horizontal there. I'm getting too much into advanced. It's okay. You don't even know that. All right, decreasing. Is this thing decreasing ever? Right here, boom. From -3 to -1, it's decreasing. So -3 to -1. What about this stretch here? It's not increasing, it's not decreasing. It's horizontal, not doing anything there. So there we go, folks. We got it all. We evaluated. We did some fun solving there. I wasn't planning on making that one difficult, but hey, it happened. So we mathed it up. We mathed it up over here. This one was a little bit easier, had 2 solutions, and then some intervals of increasing and decreasing. So a lot of different questions we can ask you on piecewise functions. Be prepared for it because really you could be tested on any of your functions that you know from Algebra 2, whether it be quadratics, radicals, Algebra 1, like absolute values. You know, those make comeback. Rational functions, not so much with rationals, but they can be there. So a lot can go on in piecewise. Be prepared for it. But other than that, hope you guys enjoyed the video. I enjoyed making it. Have a wonderful day.